Yo, what's up, everybody? Welcome back. So, we're gonna go over graphing piecewise defined functions. So, those right there, those are your piecewise defined functions. Those ones are your functions that you're gonna be graphing. Those are your restrictions. And as we already know, we kind of went over what restrictions were. Basically, it's the interval in which your function exists, right? So the first function, 2x plus 5, it's only going to exist between -6 and -3. So let's go ahead and get started. So I'm going to separate them just so you can kind of see what I'm doing. So the first one, it's f of x equals 2x plus 5. Now, if you're able to recognize it, you can tell that that is a linear function in the format of y equals mx plus b, or slope-intercept form, which means that that is your slope and that is your y-intercept. All right? Cool. So let's go ahead and graph it real quick. My y-intercept is at 5. Whoa. Which is not there. Okay. So now I got to do something different. I'm going to choose a value to plug in for x, okay? Because 5 is not on my graph. So what's going to happen if you ever encounter that problem? It's not on my graph. I can't, it's, it only goes up to 2. How can I find another point? Well, remember, a function is an input and an output, so you can pretty much pick whatever input you want. I'm going to pick an input that is in between -6 and -3. So I'm going to pick -4. So I'm going to let x equals -4, and I'm going to plug it in. So now I have 2 times -4 plus 5, right? So f of x equals 8, so -8, so -3, right? Cool. So there's my point. I picked x, which is -4, and I got -3, which is my output. So that's my starting point. -4 down -3. And now I can just use my slope to get the rest of the points. In this case, my slope is 2, so I can go up 2/1, up 2/1, and I can do it the other way around. So down 2/1, down 2/1. All right. So typically, this would be your function. Now remember, I am restricting the domain. That function should only exist in between -6 and -3. Well, -6 is right there, and -3 it's right there. So my function should only exist in between those two lines, which means that the rest of it doesn't exist. So I'm going to erase that, and I'm going to erase that right there. Okay? Cool. So here's where the complicated parts, where the complicated section begins. So notice that those two say equal to, which means that at the end of those two, at the end of the segments, at the two end of the segments, I'm gonna draw a closed circle. Okay, so if you remember, cool. All right, second function. So I got f of x equals 2 times the absolute value of x minus 7. All right. So if you remember, an absolute value should be a V shape, and it usually follows the HK form. Now, as you notice, there's no H. Because there's no H value, I'm just going to assume that it's 0. So my HK, so my H is going to be 0, and I can see that my K is actually -7. So there's my starting point, 0 down -7. So there's my vertex where my axis of symmetry is. In this case, I'm not gonna draw the axis of symmetry just because it might confuse you. too many lines. My slope is 2, so I'm going to draw the 2 legs. So starting from the middle, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, and up 2 over 1. Same on the other side. I'm reflecting the points, 2 over 1, 2 over 1, 2 over 1. Okay? So again, your function should look like that. But it also has restrictions. In this case, this function should only exist in between -2 and 1. Well, -2 is right there, and 1 is right there. So your function should only exist in between those 2 lines. Everything else, I'm gonna erase. All right, now -2, right? So what kind of circles would I get now? All right, so notice that -2 says less than but not equal to, which means that I'm not gonna have an open circle anymore. I'm not gonna have a closed circle anymore. I'm gonna have an open circle because -2 is not included. Same thing with at 1. 1 says is less than or equal or less than 1 but not equal to 1. So same thing. I'm gonna have an open circle right there. Okay, and the last one, I'm gonna do the work under that. So the last function is f of x equals -4 minus x. This is also in the format of y equals mx plus b. The only difference is that they actually swap the x and the 4, but it's still a linear function. I can see that my y-intercept is -4, so I'm gonna go ahead and put a point right there. My slope is -1, which means that it's gonna be going down, or -x. So there's a point right there, 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 there. So your function should look like that. Cool. Now back to the restrictions. Based on my restrictions, that function should only exist between 1, which is right there, and 3, which is right there. Right? Everything else should go away. So that goes away. Okay. All right. So at 1, it actually says greater than or equal to 1, which means that I'm gonna have a closed circle at 1. Now notice that there's already an open circle, but because I'm going to have a closed circle on top of it, it's actually going to fill in that empty hole. So now, instead of having an open circle, we have a closed circle. And on the other side, it actually says less than or equal to 3. So I'm going to have also a closed circle. Cool. And that is how you graph a piecewise function. You probably have a lot of questions throughout the practice. Make sure that you ask because this is a very complicated topic. Peace.